Hello, class. This is Mr. Gibson, and I'm coming to you going over Chapter 2. I know we just went over Chapter 2 this week, but I would like to have these videos readily available for you, especially since we're dealing with decimals and fractions. So let's get started. Again, chapter 2 starts on page 238. This will be probably the only time that I mention the page numbers, so you would just have to follow along in your textbook. Again, this is page 238. So we start out with decimals and fractions. Lesson 1, Decimal Basics. The decimal system. Decimals are numbers that use place value to show amounts less than 1. You already use decimals when working with money. For example, in the amount $10.25, you know that the digits to the right of the decimal point represent cents or hundredths of a dollar. The first four decimal place values are labeled on the chart below. Okay, so I'm going to write this out just like I did when we were in class. So what I'm going to do, I'm going to write out a number. Let's say we have 1, 2, 3, 4, 5 decimals, 6, 7, 8, 9. Okay. Now, we want to look at our place value. First, we're going to look at our place value in front of the decimal. Now, that is what we dealt with in chapter 1. So in chapter 1, we notice that this first digit to the left of the decimal is in the ones place. The second digit is in the tens place. The third digit is in the hundreds place. The fourth digit is in the thousands place. And then finally here, the fifth digit is in the 10,000s place. Okay, these are the place values in front of the decimals. And then you know, after we do 10,000s, we go to 100,000s and so on. Now, behind the decimal. Now, one thing I did say before is this here, that behind the decimal, it kind of mirrors what's in front of the decimal, except for there is no ones placed behind the decimal. All of the place values you see in front of the decimal, except for the ones place, appears behind the decimal, but it has TH or THS behind it. So for instance, since there is no ones place behind the decimal, this would be tenths with a TH, a THS. The second value would be hundredths with a THS. The third value would be thousandths with the THS, and then this value here would be 10,000ths with the THS. Okay, now we have our place values, and the decimal is the separator. Again, these place values mirror each other. Tens with tenths, hundreds with hundredths, thousands with thousandths, and 10,000s with 10,000ths. Now, we move on. We're going to take a look at some of these problems here. Let's take a look at example 1. Well, oh, they talk about rounding. So let's talk about rounding first before we get into example 1. And also one other thing. Let's say we look at these numbers here. Um, with rounding, we're going to first start out rounding behind the decimal, then we're going to go in front of the decimal. So there are some rules that you need to know. So let's take a look at example 1 as it's set here. We have this is example 1. We have 3.62835. Now we're asked here. It says round decimals the same way you round whole numbers. Example 1, A calculated display reads 3.62835, round to the hundredths place. Okay, so first, we look behind this decimal and we have to find the hundredths place. So remember, the first digit behind the decimal is the tenths. The second digit is the hundredths. So this is the hundredths place, the 2. But remember, just like we rounded before in front of the decimal, we go to the right of the place value we want to round. Now, there are some rounding rules here. We know 0 to 4, if the digit to the right is 0 to 4, it stays the same. The place value we're trying to round stays the same if the digit is 0 to 4. If the digit is 5 to 9, we increase it by 1. Okay, so now we look at this place value. This is in the hundreds, the 2. To the right of it is an 8. 8 falls in the 5 to 9. So we increase this 2 by 1. So this becomes 3.63. Now with decimals, there's also another rule with decimals. After you round, everything behind the place value drops off. So in other words, what I'm saying here, when you round behind the decimal, everything past that place value drops off. So your final answer should end at that place value. We rounded to the hundredths place. Your final answer has to end in the hundredths place, which we have here. So we had 3.63. Now, since I'm speaking on this, you notice this is a big difference from what we did when we rounded in front of the decimal. When we rounded in front of the decimal, except for the ones place, when we rounded, all of the place values behind that digit became zeros. For example, and this is going to be an extra example. Let's say I had 6,584, and I ask you all to round to the hundredths place. We know that this 5 is in the hundredths place. So the 8 is directly to the right of that hundredths place. It's still 5 to 9, so we increase this place value by 1. So this would be 6. This 5 would become a 6. Every digit behind it that's in front of a decimal becomes 0. Again, every digit behind, when you're rounding in front of the decimal, every digit behind it before the decimal becomes 0. Now, if we did have a decimal, if we did have values behind the decimal would just drop off. Whenever we round in front of the decimal, your answer will not have any decimals behind it. So you would just do regular rounding and anything behind the decimal would be dropped off. So this would still be 6,600 if I asked you to round to just the hundredths place, not the hundredths place. It'll still just be 6,600. Okay, so now we'll go on to example 2. Now, example 2, they just want you to compare numbers. It says Matt ran the 400-meter race in 45.8 seconds. Alonzo ran the same race in 45.66 seconds. Which runner had the fastest time? So basically what you could do is this. If we take both decimals, we had a 45.8 and a 45.66. We have to make sure that we line them up. We had a tens place, the ones place, the tenths place, and the hundredths place. And if you notice here, we don't have a hundredths place here, so we would add a 0. Now what we would do, we would go from left to right. And as soon as we get a number that's larger, that will let us know which number is the larger number. So, and it says, wait a minute, which number had the fastest time? Okay, so here's this. Let me see. This is interesting. Okay, so we look here. These tens are the same at 4, so there's no difference. The ones place are the same at 5. There's no difference. But here, if you notice, this first value is an 8 in the tens place, and this value is a 6. There's a difference. So we know 45.80 is larger than 45.66. But this is a little bit of a tricky problem because they asked us who had the fastest time. And we know the person that has the lower number has the fastest time. So 45.66 would be the answer for fastest time. But if we were looking for a larger number, it would be the 45.80. Okay, so now we move on to our next example. So with the example 3, it asks us to arrange the numbers that they're giving us 0.85, 1.8, 0.8, and 0.819 in order from greatest to least. And it says add zero so the numbers have the same number of decimal places. So what I'm going to do here for example 3, we are going to line these numbers up. Now, what I'm going to do, first, I'm going to line them up vertically. This is until we get used to these numbers. 0.8, 0.819. Now we're going to add zeros here until we all have 3 digits behind the decimal, which we do. Okay, so now we're trying to find, they want us to line these numbers from greatest to least. So we look in front of the decimal. We notice that there is only one different number in front of the decimal, and it's this 1. So we know this 1.8 is the largest number. So now we try and find the second largest number. Okay, these zeros are the same. We look behind the decimal. All of these 8s are the same. Now we go to the second number behind the decimal. We have 5, 0, and 1. So we know 5 is bigger than 0 and 1. So it'd be 0.85. And then here again, we're at that second digit. 1 is bigger than 0. So 0.819 would be the second to last biggest number. And then the smallest number would be 0.8. And that is your order. Okay, now we come here to some of the problems that we did cover in class. I'm not going to go over all of the problems. I'm going to go over a select few so that you will get the gist of the lesson. So let's go here to number 1. Matter of fact, I think I'm going to do mostly the odd numbers, but I shall see. So we do number 1. First, we read the directions. It says round these numbers as directed. Number 1, round 3.75 to the tenths place. So we had 3.75, and we have to know our tenths place. Our 7 is in the tenths place because that's the first. The tenths place is the first digit behind the decimal, to the right of the decimal. So we have to go to the place value to the right of it. Now we know 5 falls into 5 through 9. So that means that we raise this value up by 1. So it'd be 3.8, and then everything drops off behind the decimal. So number 3. It says a calculator display reads 0.4285714. Round to the nearest hundredth. So we have to find the hundredths place. The hundredths place here is the 2. So we go to the right of it. This 8 falls in the 5 through 9. So then we know we raise our hundredths place up by 1. So it'd be 0.43. And I'm using these squiggly lines because that means approximation. Okay, now number 5. It says round 8.125 to the nearest tenth. So we have 8.125. The tenths place is the 1 here. So we'll go to the right of it, and that 2 falls in 0 through 4. So this 1 remains the same, and everything drops off behind it. Now, there is one other number I would like to do, and that's problem number 2. And problem number 2 is interesting because we have 5.908, and it asks us to round to the ones place. Now, this 5 is in the ones place. So we go behind this decimal to the first digit. This falls from 5 to 9. So we take the ones place and add 1 to it and make it 6. And everything behind it drops off because everything behind it is behind the decimal. So your final answer for number 2 would be 6. Okay, now we drop down to problem number, I'm going to go with problem number 9. I'm going to skip 7 and do 9. So we have 4.68. Now they're telling us in each of the following pairs which number is greater. So we're going to line these up, 4.68 and 4.086. So we'll add a 0 here, and we make sure they're lined up. In front of the decimal, they have the same number. First digit behind the decimal, the 6 is larger than the 0. So our answer here would be 4.680 or 4.68. That would be our answer because we want the number that's greater. Okay, now the next number we would do is problem number, let's see, problem number 11. Still, we will line this up, 1.0275, 1.029. Again, in front of the decimal, the values are the same. The first digit behind the decimal the same. The second digit behind the decimal the same. The third digit here, 9, is bigger than 7. So our final answer will be 1.029. Okay, now we drop down to problem 13. Okay, problem 13, they want us to line these numbers up from least to greatest. So with problem 13, I'm going to line these up vertically first. 5.6, 5.08, 5.8, and 5.802. Now, we would add zeros here because we had 3 digits behind the decimal, so we must make sure that all of these numbers had 3 digits behind the decimal. If you notice here, all of the numbers in front of the decimal are the same. The first digit behind the decimal, we had 3 different values here. We got a 6, 0, and 2 8s. Now here we could figure out what the lowest value would be. 0 is lower than all of them. So they want us to line this up from least to greatest. So 5.080 would be our first number. Next, 6 is less than 8. So the next number would be 5.6. Next, now we have our 5.8s here. Then we have a 0 here, which is the same. And then we have 0 and 2 here. So we know 5.8 is smaller. And then 5.802 is the largest. So that will be it for problem 13. Okay, problem 15. We're going to do the same thing. Problem 15, we're going to line this up. We have 14.005. We have 4.52. We have 4.8. And we have 4.667. Now we had 3 digits behind the decimal, so we're going to make sure that all of them had 3 digits behind the decimal. Okay, now we look here. 14 is the largest. We know 14 is larger than the rest. So 14, this 14.005 will be the last number. Now we look at the next 3. They all have 4 in front of the decimal. Then now we look at 5, 8, and 6. Now we know 5 is the lowest. Well, let's do this. Since these three, all three of these have three different numbers, let's go with the highest number first. So it'd be 4.8. So we know it'll go in front of this 14.005. Then it'll be 4.667. And then finally, first it'd be 4.52. And that is your answer for problem 15. Okay, now our last problem. Let's look at 17. Problem 17, it says in a circuit board assembly, the weights of three parts are 0.52 grams, 0.0785 grams, and 0.6 grams. Which of the following lists the weights in order from greatest to least? So we can line this up. 0.572, 0.0785, and then 0.6. Okay, so now the longest one we have is 4 digits behind the decimal. We add these zeros, so we have 4 digits behind the decimal. Now, if you look here, we want to go from the greatest to the least. All of them start out with zeros in front of the decimal. They're the same. So now when we get to the tenths place, we have three different numbers, which makes this easiest. The larger number is the 6, so 0.6 will be first. And then the 5 will be second, 0.572, and then finally 0.0785 will be last. And the one that has that is C. Okay, now, but 18, I'm going to do 18 because that's a rounding problem. It says, which of the following correctly shows 1.3815 rounded to the nearest hundredth? So we got 1.3815, and we want to round to the nearest hundredth. So we go to the hundredths place, which is the 8. We look to the right of that. Now this falls in the 0 through 4, so then that means the 8 stays the same. So our final answer would be 1.38, which would be D. Okay, now that is it for this lesson. Okay, I will upload this to YouTube and send you all the link.